Hello everyone, my name is Indhumathi. I am assistant professor in electrical and electronic engineering. I am working in PSN College of Engineering and Technology. So today I am taking the topic of electric vehicles. Because of this electric vehicle is emerging one, and this is very needful to us. So we take this electric vehicle importance and what is electric vehicle and what is hybrid electric vehicles and many more topic. So later we discuss. Okay, so let me start. First of all, need of electric and hybrid vehicle. Okay, need of electric and hybrid vehicle. So first of all, electric is run by battery. This is a pure electric vehicle. But in the sense of hybrid vehicle, so the vehicle run by battery and itself engine, that is petrol or diesel vehicle. Okay, na? So there is a need over dependence on petrol or diesel. That's why we prefer the electric vehicles. Then rising petrol or diesel prices. This is a very important issue in our day-to-day life, because of we are using everyone using the vehicle. So we are considered as electric vehicle is a best vehicle. So that's because of the rising petrol or diesel prices. And the pollutions and the resultant global warming. So the global warming is change every day, so that's why we ready to move to electric vehicles. Then noise in conventional vehicle, so the noise and the need of alternate power sources. Then need of eco-friendly and EV and hybrid, the solution of that diesel and petrol engine. Okay, so upon next there is the advantages and disadvantages of electric vehicle. The right side of the PPT, the advantages and disadvantages of the electric vehicle. So first of all, the advantages does not depend on fossil fuels, that is the petrol or diesel or gas. And the electric vehicles are known for their always on power delivery. And the electric vehicle are silent operator, that is a comfort zone. And running on electricity mean goodbye to exhaust gases. Because of we use electricity, we have no smokes and we have no pollution to environment. At the same time, the electric vehicle have some disadvantages, that is the price, the initial price is 30 to 40% higher than their regular vehicle. Then charging infrastructure are not adequate, because of we supposed to use the electric charging in our house, because of the charging infrastructure is not adequate. Then driving range, so the driving range offered by a battery technology is not adequate. Then battery pack that power them are highly sustainable to wear, tear and expensive. So the next slide, what is electric vehicle? So the electric vehicle, the left side you all see the diagram of the electric vehicle. So the vehicle is charging process. So the EV refer to any vehicle powered in part or full by a battery that can be directly plugged into main. So this is a charging station. Then pure electric vehicle. What is pure electric vehicle? So the electric vehicle powered only by a battery, that is a pure electric vehicle. Then plug-in hybrid electric vehicle. So the Golf GTE, that is a plug-in hybrid electric vehicle. So the hybrid electric vehicle consists of both battery and what? That is the petrol or IC engine. Have an internal combustion engine, but also a battery range is excess of 10 miles. So 10 miles means that is 150 kilometers. Then after the battery range is utilized, the vehicle reverted to full hybrid compatibility, utilizing both battery and IC power without compromising the range. So there is no compromise of the vehicle distance range. Then extended range electric vehicle. So the EV, the E or EV, that is extended range electric vehicle, this is similar to pure EV. Okay, but a shorter battery range, this is 50 miles. But in the hybrid electric vehicle or pure electric vehicle, the range is 100 above. But in this HEV, 50 miles. However, the range is extended by IC driven generator, providing many additional miles of mobility. So with the E or EV, the propulsion is always electric, unlike a PHEV, where the propulsion can be electric or full hybrid. So this is structure of the hybrid electric vehicle. So the structure of the hybrid, the inner structure. So the yellow color, in yellow color the mark is electricity, and the red color mark is fuel, and this orange is a propulsion. So the powered by both IC engine and battery. So the IC engine means the red color and battery means this yellow color. The power source is selected automatically by the vehicle depend on speed, load, battery charge. Battery cannot be plugged in. Charge is maintained by regenerative braking, supplemented by IC engine. So the structure of the hybrid electric vehicle. So note it down. Then the second life of electric vehicle batteries. After we delivered 50,000 kilometer or 1 lakh kilometer, we utilize the battery. Then it's considered to a recycle process. That is, at the end of the life cycle in the electric car, the battery is still valuable. First of all, we have to refabricate and reuse in instead of grid stabilization. In that grid stabilization, we use the refabricated battery. So ELV, that means electric vehicle, direct to encourage good product design. Example, avoiding use of harmful heavy metals, increasing use of recycled materials, and designing the car components and material for easy reuse or recycle. So this is the emission chart diagram. So first of all, in the right side, it is a fuel vehicle. That means pure fuel vehicle. The CO2 gas is emitted and the NOx is emitted and the PMS there. But in EV charged on grid, only from grid, that means power generation from nuclear power plant or thermal power plant. So that is a grid. So that is the COD is happened, and 2.3 because of COD is from which happened the thermal power plant. So this is also harmful, but the EV charged with renewable sources, that is wind and solar. So from that wind and solar, we have no pollution to environment. This is the chart diagram of the emission control. Okay. So the pure electric vehicle charged with a renewable source. Suppose we have a household charging point, the charging supply 50%, minimum 50% at least have from renewable, and remaining 50% you have your choice from grid, because of we paid the electricity bill. So that's why I told. Then cable. So the cable is insulated to prevent contact and short circuit. So the orange color point is the cable. This is the battery. Then most cable are made from many strand of copper wires, as these offer low resistance and retain flexibility. Insulation is normally a form of PVC. It's a PVC, you know about PVC pipe, that's a strong material. From the strong material that is in the insulation. High voltage cables require greater insulation to prevent voltage leakage. The risk of harm if touched is very high. Stickers with various symbols are used as a warning together with a bright orange color, that is the cable. To deliver a high power, they have to carry high current even at a high voltage. So we use this type of cable. Because of this, the capacity is 250 voltage. The cable has delivered say 20 kilowatts, 80 amps range. And the hard acceleration, that is, this is even higher, 80 kilowatt would require a current of 320 amps. To me, these cables are quite thick as well as insulated. So next we discussed about the components of EV. So what are the components done in electric vehicle? That means battery, the main part of the electric vehicle is battery, motor, control unit, charger, inverter, battery management control, driver display interface. So first of all, components of EV. First, what's the first component? Battery. So the mostly we used lithium ion battery. In this recent years we use lithium ion battery because of this is lightest material and the heavy available material is a lithium ion battery. And installed under body of the car, which weight over 300 gram. Very good, kilogram. Complete battery pack consists of 200 to 300 cells model, cooling system insulation, junction box, battery management and shell. Battery is able to withstand impact and a wide range of temperature. Then motor. So the motor is converted from electrical to mechanical. So the electrical is power get from battery, that is the convert electrical energy into kinetic energy or movement, that is a mechanical energy. Types of AC synchronous motor supplied with pulses of DC rated in range of 85 kilowatts on pure EV, 84 kilowatts. Then control unit. So the control unit called power control unit or motor control unit, that is a controlling device. Respond to signal from driver, that is mean brake or acceleration. Suppose the driver put a brake and cause the power electronic switch to be accordingly. The control make the motor drive the car or become a generator and charge the battery. So these are all happened by this control units. Next components is charging point. So the charging unit usually located near where external power source is connected. Convert and control the main voltage, typical 230 bar 240 volt AC in Europe and 250 volt AC in USA to a suitable level for charging battery cells. Then inverter. The inverter is convert from DC to AC. Because of suppose we use the motor is AC, that's why we convert from DC to AC. Also does this reverse for regenerative charging. Sometimes the same or separate inverter is used to supply 12 volt system. Then battery management controller, that's a BMS. So this battery management, it's a monitor and control the battery, determine the state of charge of cell, because the notification from the battery, this is 10% charge, this have 5% charge. So that's a notification get from this battery management controller, and it regulates the temperature and protect the cell against overcharging and deep charging. And electronically activated switches or insulated included that disconnected the battery system when idle and in critical situation such as an accident fire. This is the driver interface. So the driver interface, how much of charges happen, how the state of charges, what amount of current is getting from the battery. So that's all information get from this driver interface. So to keep the driver informed, a number of methods are used. Most common now is a touch screen interface where information can be delivered as well as allow driver to change settings such as charge rate. This is the layout of EV. So from this EV, this is charging station. First of all, the charging station, and the onboard charger is our vehicle inbuilt. Then drive battery. From that battery, we give the DC to DC converter and 12 to 24 volt because of this is the auxiliary battery. This auxiliary battery is given to small electronic components in our electric vehicle. So supply the electric energy. From the electric battery, the drive control and the motor, transmission, and then finally wheel will rotate. That is the electric vehicle layout. And battery range. So distance covered by e-vehicles per battery charge. Lead acid battery are capable up to 130 km per charge. Lithium ion battery up to 480 km. So that's why we use lithium ion battery. So smooth driving with a gentle acceleration and minimal braking has most impact on battery range. Range is also affected by cold weather as well as use of air conditioning, heating or cooling. Battery charging section. So this is a clear diagram. The left side diagram is a clear diagram of battery cross section. So we have two classification. The one is primary cell and another one is secondary cell. So the primary cell cannot be charged and the chemical process not reversible. Zinc, carbon and alkalis. This is a primary. We used our normal mini project or a clock or battery small remote car. In that things we use the primary cell. And the secondary cell, it's a recharged battery and chemical reaction will be reversible. So that's why we use lead acid battery and nickel cadmium, nickel metal hydride and lithium ion battery. So in this from this four types we use lead acid battery in previous and now one and only lithium ion battery. This is the positioning of the battery in EV. We all understood, I think. Then battery type: lead acid battery, alkaline battery, sodium nickel chloride battery, sodium sulfur battery and lithium ion battery. Now we discussed lead acid batteries and lithium ion batteries. So what are we required for this battery? This is safe because of if the battery is burned, the smoke is heavy in that 1 kilometer range. That is, safety is first requirement. High power and high capacity and small and light, large format and long life, low overall cost. These all are the battery requirements. Then lead acid battery. So this is a practical lead acid battery diagram. So the negative electrodes contain lead, that Bb, lead, while the positive plates have BbO2 as active material in charged state. Electrodes are immersed in electrolyte of sulfuric acid. When being discharged the lead and the lead dioxide react with the sulfuric acid. That's a reaction equation. The lead plus lead O2 plus 2H2SO4 gives 2BbSO4 plus 2H2O. So lead sulfate is formed on the electrode and the electrolyte losses dissolved sulfuric acid and become water. Energy is released during the chemical reaction and when energy is added the process will reverse. Lead acid battery. This is the lead acid battery, the outlier diagram, modern vehicle battery. Best choice for low voltage motor vehicle, that is the lead acid battery. If we use low voltage motor, we use lead acid battery as the best recommendation. And low cost, high energy density. Nominally 12 volt battery consists of 6 cells connected in series. Each cell producing 2 volt is household. Individual compartment in a polyfrail case. Modern batteries are sealed. In the previous, this is not a modern battery, this is a old type battery and this is a modern type battery. Precaution: clean and corrosion from terminal use hot water. Terminal should be smeared with petroleum jelly or Vaseline. Battery top should be clean and dry. If not sealed, cell should be topped up distilled water 30 above the plates. Then we discussed about lithium ion battery. So why we use lithium ion battery and what is lithium ion battery, we will discuss deeply. So the dominant battery technology in BEV and HEV. Then of all the metals, lithium has been highest standard potential and electrochemical equivalence. Lithium is the lightest material and energy density 140 to 280 watt per kilogram. Anode LiC, electrolyte LiBr. Cathode lithium cobalt oxide, lithium ion are deposited between this layer. So this is if the charging time, the electrons is coming from cathode to anode. If the discharging time, the electrons are coming from anode to cathode. In the discharging time, the load is low. So in cold condition, lithium ion movement is slower during the charging, which tends to make them reach the electrons on the surface of the anode range than inside it. Research is ongoing, so no possible solution could be warm tube battery before charging. So this is the lithium ion battery, the Bosch media. So this is the same Bosch media lead acid battery, and this is lithium ion battery. So comparatively to the size is very small and it occupies less space. So that's why we use lithium ion battery. So in battery plug-in and life. So main source of lithium for EV battery are salt lake and salt pack, which produce soluble salt lithium chloride. Lithium can also be extracted from seawater. Worldwide reserve are estimated to be about 30 million tons. So the main producer of lithium in South America, so Chile and Argentina, Australia, Canada and China, the main producer of lithium. So from South America, okay. Then around 0.3 kilogram of lithium are required per kilowatt hour of battery storage. So the lithium is extracted from South America, that is Australia, Canada, China. Battery plug-in life. End of the life of battery is considered when battery capacity dropped to 80% of rated capacity. That is the end of the life. And if battery has range 100 km from full charge, after 8 to 10 years we use range reduced 80 km, the battery range, that is the life is reduced. However, the battery can still deliver usable power of 80% charger capacity. Recycling will become a major source of lithium. Lithium ion cells are considered non-hazardous and they contain useful elements that can be recycled. Lithium metal, copper, aluminum, steel, plastic, cobalt and lithium salt can all be recovered. So this is the roadside charging point, this is the domestic charging point. So from the roadside charging, it is a faster one, but in the domestic charging it is a slower one. Okay, so but the cost wise the domestic charging is better. So charging time. In previous slide we saw the roadside charger and domestic charger. So we will discuss pure EV capable of using rapid charge point and full charge in 30 minutes at top 20 minutes depending upon the type of charge point and available power. So hybrid electric vehicle take approximate 2 hours to charge from the standard electric supply. So 6 to 8 hours take the time to charge, that is single phase supply. That is the power depending on the charge point and power. So the power. So 230 volt and 16 amps. In that at the same 3 to 4 hours single phase also available. Then 1 to 2 hours 3 phase 32 amps is also available. Then 20 to 30 minutes the time will reduce because of the time is reduced. There is the roadside charger. So in this roadside charger, the DC current also available in the charging station. Then charging cost. The cost of charging EV depends on the size of the battery and how much charge is left in the battery before charging. So this is the charging cost. This is dependent. Charging the electric car from flat to full will cost from 124 for 24 kilowatt battery per 100 mile range. Overnight charging is advantageous, cheaper rate when there is surplus energy. That is a very important one. Cost of charging from public point will be vary. Then charging method. So there are three types of method: AC charger, DC charging and inductive charging. In our home we only use AC charging. In the roadside charging we use AC charging and DC charging, and the inductive charging is the wireless charging. That's the inductive charging. First, AC charging. AC charging is the household single phase. So clearly show the diagram: single phase and SAV J1772. So type 2 is a vary from US, European and China, Japan. And the single phase or three phase also in AC charger. So three phase. Then DC charging, that is from what? Charging station. Okay, so that's why this DC charging is faster than AC charging. AC charging. From our home we have an individual supply from the electric vehicle, then put the charging. So establish standard charging method. Charging occur via AC connections. Most common and flexible charging method possible in private sector, and charging station in semi-public and public sector with low investment. In charging mode 1 and 2, charging is possible on household socket. On the household socket, charging can take up to several hours due to power limited to the socket. This is the AC charging. And in charging mode 3, a vehicle can be charged at a charging station when power of up to 43.5 kilowatt is possible with a significantly reduced charging time. Charging device is permanently installed in the vehicle. Its capability is adjusted to electric battery. Compared with other charging methods, investment cost are moderate. Then DC charging. So the DC charging only available in the roadside charging. So DC low charging up to 38 kilowatt. Low charging is range is also 38 kilowatt, and high DC high charging is 170 kilowatt. Charging device is part of charging station. Expensive as compared with AC charging station. Prerequisite. Then DC charging. So the continuous of DC charging. Standardization of DC charging connection has not yet been concluded and market availability is still uncertain. In practice, vehicle with the DC charging connection have additional connection for standard charging, so that vehicle can also be charged at a home. Inductive charging, this is an interesting topic. That is a wireless charging. So the high frequency inverter voltage gain compensator network, that is the road and vehicle current gain and compensation network. So from this the road and vehicle, that is a wireless power transfers happen. So that is a transmitter and receiver is connected in that road and vehicle. So the vehicle is automatically charged from this rally, in particular rally. So the type of short distance wireless charging, no physical contact between the transmission and receiver, work on the principle of electromagnetic induction. Charger will create an EM field with alternating polarity using a coil insulated wire of copper, and similar copper will be placed inside e-vehicle will convert EM field back to electric current, thereby charging the battery. So different mode of charging. The mode 1 is household. The mode 2 is household outlet also, but it is a AC charging in 3 phase. The first one is single phase. Then mode 3, that is a dedicated EVSC, that is the roadside charger, and this is a production function. And mode 4, this is a pure DC charger. This is a fast charging. In 10 minutes they can up to 100 km per hour distance we charge. So the wireless charging and wireless power transfer is innovative system of charging the battery in an electric vehicle. the wireless power transfer vehicle is parked, no driver in the vehicle. Quasi-dynamic wireless power transfer vehicle, stop, driver in the vehicle. And dynamic wireless power vehicle is in motion. So also 3 power class. So static, quasi-dynamic and dynamic. So static means the stationary in a vehicle, the vehicle will be charged automatically, and quasi-dynamics we will stop and we will move. Suppose what may be happen, the vehicle will be charged, and the dynamic means only in motion the vehicle will be charged. So light duty home and light duty fast charge. This is static wireless power transfer. Static means the vehicle, suppose the vehicle stop position, the power is transferred from wireless power charger to vehicle. This is static. The vehicle is stopped and it is static. So these are all the consist of primary power supply with the track and the secondary pickup and the pad and control. Electrical power from main and energize a lumped coil with the current in the range 5 to 125 amps. So these are all the charging range current. A coil in inductive compensation using series or parallel capacitor may be required to reduce the working voltage and current in the supply. Pickup coil or magnetically coupled to primary coil. So power transfer is achieved by tuning the pickup coil to the operating frequency of primary coil with a series of parallel capacitor. Power transfer is controllable with a switched mode controller. So let's start the vehicle, and the vehicle drive to up to 150 kilometers after the charging. So in that wireless power transfer charging, so static, dynamic and quasi-dynamic is also possible in wireless power transfer. So the wireless power transfer only in the form of AC, because of in the it's like a transformer. The primary coil is wounded on the transmitter, and secondary coil is wounded on the receiver. The transmitter is the charger, receiver is the car. So the power is transmitted from charger to a vehicle with the help of transmitter and receiver. So that is the static wireless power transfer. So this is the electric vehicle structure. Electric vehicle. This is the electric vehicle. What is electric vehicle? Why we use electric vehicle? Definitely in our future we have to use the electric vehicle because of our nature. Nature is polluted so much of amount. That's why we have turned to electric vehicles. We save the nature and we help the nature. We have to help the nature. Thank you so much. Thank you.